I'm really nervous about this talk, and when I'm nervous, I like to think about the people I know who give really awesome presentations. And so today I'm going to ask myself, what would Tenderlove do? And Tenderlove would wear a silly costume. Check. And Tenderlove would show you pictures of his cat. That's my cat, that's Nick. Check. So a little bit about me. My name is Ajay Hammerly. I tweet very seldom at ThagAmizerRB. I'm on GitHub as Thagamizer. I blog even less often at thagamizer.com. And I work at an awesome consultancy in Seattle called Substantial. And I've heard they're tuning in right now to the live feed, so hi guys, thanks for supporting me. So during the last 8 years or so, I've helped 2 companies increase their use of automated tests and specifically unit testing. And during that time, I've had some truly fantastic mentors from the Seattle Ruby community. And I've also had a chance to mentor several people who had never really done unit testing or automated testing before. And I noticed a lot of patterns, a lot of things that people did that were good, and a lot of things that people did that came back to bite us. And so during this talk, I'm going to pass on some of that knowledge. And the first thing we really need to talk about is what makes an effective test. And I have 2 really simple metrics for whether or not a test or a test suite is effective. The first one is that a test should be trustworthy. And by trustworthy, I mean that if it's passing, the code's great. Everything's working, you can trust that things are okay. And if the test is failing, something better be wrong. You need to be able to trust your test to tell you the state of your code accurately. But it's not just that. A good test suite is also simple. Simple test suites are easy to use, simple to write, simple to extend, and simple to debug when something's going wrong. So a brief overview of my talk. I've organized the anti-patterns into 4 broad categories: pointless tests, tests that are a waste of time and effort, false positives and negatives, and inefficient tests. And this talk has got a lot of code examples, and I'm going to go through them pretty quickly. But before I hit them, I want to point out that there's a mix of pure Ruby and Rails code. I use test unit, RSpec, and Minitest in different examples, and I'm doing this very, very purposefully. The anti-patterns I'm covering are framework agnostic. In fact, they're language agnostic. None of these are specific to Ruby. So you can't just say, oh, I use RSpec, I'm immune, or I use Minitest, these don't apply to me. These apply to everybody. These apply to every language. You may be lucky and not have any in your code base, but you probably have a few. So let's dive straight in to pointless tests. And the first example of that is not having tests at all. Found this great quote on Twitter on Tuesday as I was coming to the conference. We're coding too fast to write tests is the same as we're driving too fast to confirm we're on the right road. Tests are your safety net. They're what let you take risks, try things out, see if you can make your code better. Solution to that anti-pattern is to write tests. If you don't believe you need to write tests, turn to the person next to you and ask them to tell you why, because I have more interesting things to cover. So the second in the pointless test category is not running the tests you have. See that very, very lazy cheetah right there? Yeah, that's not running. And if you're not running your tests, you're like that cheetah. And the worst part about not running the tests you have is that they're worse than not having them. You spent time writing them, and you're getting no benefit whatsoever from them. So use continuous integration. Having continuous integration means you can't forget to run your tests. And my experience is that there are a ton of continuous integration systems out there, and none of them are perfect. So pick one that's good enough, hook it up, and make sure that your tests run on every check-in. That will solve that problem. But having continuous integration isn't sufficient. You also need to listen to your continuous integration build. Failing tests are telling you something is wrong. If your team culture is to ignore a red CI, you need to fix your team culture. I've been there, I know it's tough, but it is totally doable. If your team culture is, well, we don't worry about when that test fails because that test just randomly fails sometimes, that's an untrustworthy test. Fix it. If your team culture is, well, that test isn't really useful, delete it. Failing tests are broken windows in your code. You need to fix them so that the whole neighborhood doesn't suffer. On to more interesting things, wasting your time and effort. So the first example of this is testing other people's code. And I see a lot of people who are new to unit testing and new to Ruby and Rails do this. I did this a lot at the beginning, and I had people say, what are you doing? You're wasting your time writing that test. So here's a great example. This is testing a find order by ID in Rails. So create an order object, use active record find to find it, and then verify I got the one I just created back. Newsflash, active record's been tested. This is testing active record. You don't need to waste your time testing it. Someone's already got that for you. So what should you do instead? You should test what you provide. So if in your documentation, if there's examples of code that you provide, or you have specific methods in your library, make sure those are tested. If you're calling into a library, test that you're using it correctly, and also test that your code responds to output from that library correctly. There's two sides to that, calling in and handling output. And for the people in the audience who are thinking, well, I have to test the library because I don't trust it, no. If you don't trust the library, try not using it. There's probably an alternative on GitHub. You can do some Googling and find it. And if you really have to use a library that you don't trust, go ahead and write the tests against it, but submit a pull request to the library author so that other people can benefit from the work you just did. Don't make someone else do the same work you just did. Be polite. Share. So don't write that test of active record find. Another example of wasted time and effort is assert nothing raised. And I read a blog post on Monday that said this is the 9th most commonly used assertion from test unit. That's kind of scary because you don't need it. For those who aren't familiar with it, assert nothing raised takes a block, and if any of the code in that block raises an error or an exception, the assertion fails. So here's some code that uses assert nothing raised, and here's what happens when it runs. We have a failure, and we get a line 9 error, and that's the line that the assert nothing raised was on. So there's a couple problems with this. The failure is reported on the line that contains the words assert nothing raised. It's not reported on the line inside that block that actually had the error. The failure also doesn't tell you what line in your implementation caused the error. So you have exactly no information for debugging other than somewhere in this block, something that it called failed somewhere however many layers down. It's really hard to figure out what's going on. Also, you don't need it, so you have unnecessary code. And I like deleting unnecessary code. It makes me very, very happy. So here's how you can leave it out. I've just deleted it. It's all you have to do. And here's what happens when I run the test now. The code still raises, and a raise is an error, not a failure, but your test still doesn't pass. And now I get 2 pieces of useful information on the top of that stack trace. One is the line in my test that raised the exception, and the second is the line in my implementation that raised the exception. So, and if there was more stack trace, you'd get even more of that. So you'd know exactly the path the code just went through to cause that error, and so you could debug it and figure out why there was an error and how to deal with it. Also, less code better, as long as the code's still clear. On to false positives and negatives. These are the worst. Every time I've had a company that's been resistant to adding unit tests or resistant to trusting their unit test framework, it's because someone somewhere in the management chain has been burned by a test suite that gives lots of false positives or false negatives. This is all about having that trustworthy test suite. And so I'm going to cover a couple examples, but there are more, and if you find me at the Hackfest tonight, I can show you some of the ones that had to get cut for time. So the first example are time-sensitive tests. And all of the code I'm going to show you, I have seen at a previous job of mine, not Substantial. Substantial's awesome. And I've distilled it down to something that'll fit on a single slide. But this is mostly real code. I'll give you guys a second to look at this one. The output of this was that this test mostly failed during our business day, or mostly passed during our business day. But if I was working late at night or at a Hackfest or something and checked in after 8 p.m., this test would fail. And usually if I was checking in that late at night, I wouldn't have my full brain available to me because I am not a nighttime person. And I'd say, okay, I'd spend like 10 minutes debugging it, and then I'll deal with it in the morning. Or I'd email our team in Bulgaria, who would come in earlier than me, and they could deal with it. And no matter who picked it up the next morning, it would be passing again, magically, because it was time sensitive. And this is only a 3-line test. The actual test that was failing was about 15 lines, about 50 lines of implementation behind it. So it took us almost a year to figure out what was up with that test. And during that time, this test got branded as that test that fails sometimes. And so, you'd check in, and that test that fails sometimes would fail, and you wouldn't think about it. And the CI would be red, and you'd check in something else, and that would fail a different test, but you're like, that test that fails sometimes is failing, so I don't have to worry about the red CI right now. So how do you get around cases like this? Well, the simplest solution is to stub time.now. So you add a single line, stubbing time.now, and setting it equal to a date, in this case, we get midnight as the timestamp. Now this test is no longer that test that fails sometimes. This test will always pass no matter what the local time is. To make this even more fun, mix in a CI server that runs in UTC, and all sorts of joy breaks loose with time-sensitive tests. So this is another example, same job. We had a marketing team that very much wanted a promotion that ended on a specific day. So hard code that date in, and when I wrote this code, it was probably 2010, maybe 2011. And so we had like a year and a half, almost 2 years where this code passed regularly. And then the 13th of December 2012 rolled around, and magically it starts failing again. And you're like, we haven't touched that code in months. What could be going on? Well, that's that hard-coded date right there. So how do you get around this? You use relative dates. Active Support has the from now and .ago methods, and they're fantastic for this. And I've argued with people before about why they can't use relative dates. They're like, well, our spec says we have to have this hard-coded date in the code. Well, make that the default, but give yourself the ability to pass in a different date from your test, which is exactly what I've done here. So now our test says that the expiration is 3 months from now, so we won't have that joyous December 13th problem. It'll always pass no matter when the test is running. Order-dependent tests. These are one of my favorite anti-patterns. No sarcasm there. Order dependency happens when your test leaves state around. And by state, I mean things like variables with values in them, database records, files, basically anytime your tests don't clean up after themselves and put the system back where it was when they started, you run the risk of order dependency. So this is a very loosely Rails-based example. We're going to test create record and create a lion because of our animal class, and we're going to assert that it's not no, and then we're going to test find record, and we're going to find that lion we created in the first test and assert that we can find it. And yes, this is testing other people's code. I'm doing this for illustrative purposes right here. So we run the tests, and I'm running them in verbose mode here so you can see what order they run in. And first the create test runs, and then the find test runs. And I should point out that this is test unit test, and that's actually really important in this case. So now we've got create and find working, so we're going to add delete. So we add a delete test, and so we find that lion we created in the first test and we found in the second test, and we delete it. Added a test, let's rerun things. Create test passes, our delete test passes, our find test that was just passing now fails. So, interesting fact about test unit that I didn't know for the first couple years I wrote Ruby. It takes all the tests in a file and orders them by name, and then runs them in that order. So our delete test will run before our find test, even though the delete test is further down in the file. This is a really simple example because there are only 3 tests. I spent 90 minutes once debugging this in a file that had 75 tests. That was fun. So this is a perfect example of order dependency. And you can't actually fix order dependency very easily if you've got it baked into your code, but you can find it easily by randomizing your tests. This means that your tests will run in a different order anytime, so that if your tests start failing, you know that you have some order dependency hidden somewhere. Here are the default run orders for some of the standard Ruby test frameworks. Test unit, as I just said, runs alphabetical. RSpec, I believe, runs them in the order in the file. That's what I tested and found. If someone correct me afterwards if I'm wrong. And Minitest, by default, runs your tests randomly. One of the reasons I love Minitest is you can't forget to make them random. Here's how you randomize for those same test frameworks. In Test Unit 1.9 and 2.0, you can add def self-test order random, and that will randomize your tests. RSpec gives you --order rand, and you don't have to do anything for Minitest. Pro tip on this, based on an experience I had a couple months ago, if you're running your tests in your random order and you're new to this, if your tests randomly fail because of an order dependency issue, record the seed you're using. Because if you do what somebody did that I was working with and close your browser window or close your console window, because my environment must be messed up, it's going to take you a while to come back to an ordering a random seed that will give you that same order. Also, my experience with guard, if you're using it, is that it uses the same random seed for each guard session continuously, so you're not actually getting a ton of randomization there. So remember your seed. All of these frameworks will let you rerun in the same order they just ran so that you can diagnose and fix any order dependency issues you run into. Bonus fun for the advanced people in the audience, Minitest Hell runs your tests in parallel. All you have to do is require Minitest Hell and then watch things explode. It's awesome. So test that can't fail is another really common anti-pattern I see in folks that are new to unit testing. It also happens to me when I'm really tired and I forget to put my assertions in my tests. Tests generally need assertions. So I also run into this when I really heavily stub and mock, because I'm just basically asserting that the code I just wrote, or the code I'm about to write, is the code I just wrote. I'm not actually asserting what happens is what I want. We're going to look at a really simple example. Basic user class, active record style. It has a name, that's it. And I think everyone's probably pretty familiar with Rails, but if you're not, active record provides the .all method that lets you get all of the records in the table. And for this, let's say that I'm going to implement a feature so that .all returns the records sorted by name as opposed to being sorted by primary key, which is the default. So I write this test, I create a user named Ben, I create a user named Nick, and I assert that user.all.should equal Ben and Nick in that order. I want them to be in alphabetical order. And I'm going to be a good TDD person right now, and I'm going to run them. And they pass. So I've just written a test that fails without my implementation being written. Not a good thing, and something that a lot of people stumble into on accident on a fairly regular basis. So the reason this failed, or this passed, was because I created my users in the order, in alphabetical order. And then I asserted that they came back in alphabetical order. So the way to fix this, first of all, make sure you always watch your tests go green, or go red, then green, then refactor. Red is important. Red is very, very important. To fix it, all I have to do is swap the creation order so that I'm not creating them in alphabetical order. Now if I run this, the test will fail, and then I can go write my implementation and make it pass. And I know that that test is now validating something useful. On to my last category. This is the code-heaviest part. We're going to talk about inefficient tests. I've heard a bunch of hallway conversations and had some hallway conversations about slow tests. But inefficient tests, I think, is actually a more useful category to talk about. So we're going to start with requiring external resources. Some examples of this that I've seen. Using the internet is a huge one. Maybe you want to call out to your authentication service to verify your code that uses your authentication service, or you want to call out to a payment service in your tests. I've seen people use network resources that are on their corporate network so that they can only run their tests when they're on their corporate network. Maybe they want to grab something off of a specific file share or access a specific database. I've also seen people write tests that use files that they don't check into source control. Everything you need to run your test should be in source control next to your tests. And finally, I think of requiring extra setup tests beyond the standard rake or rake test or rake spec as requiring external resources. You're requiring someone to read your README and follow your extra steps as opposed to just including them in your rake file so that it's easy for people. To demonstrate this, I'm going to focus on the internet case. And so right here is a web service called Clever. I'm accessing a web service called Clever. Clever is a service for getting roster information about school districts. And so this test, all it does, or this implementation, all it does is call their district's API with their demo key, and that returns information about their demo district. And I'm using curl because I want something simple and I don't need anything more complicated. So there's the implementation. Here's a basic test. New up a Clever object, and then assert that when I call the districts method, I get demo somewhere in the results. Pretty straightforward. And run the test. They're passing. But this single test took 1/4 of a second. And I don't know about you, I don't want to wait that much time for a single test. Also, if the external service goes down for maintenance or they change their API, my tests are going to fail. And that means that I'm going to be failing because of something that someone else did, which gets me dangerously close to that testing other people's code anti-pattern we already discussed. And finally, if you're at a conference where there's bad Wi-Fi, or on an airplane, or at a coffee shop, your tests are either going to fail, or they're going to go really, really slowly while the network connection times out, and then they're going to fail. And neither of those things is going to help you get your job done. So the obvious answer is to mock and stub external resources. Someone already mentioned WebMock this morning. I like it. I've included it in a project where I was working with some testing newbies, specifically to prevent them from accessing the internet. But I think that if you have a very specific use case, there are other ways you can do that using the power of Ruby and not having to pull in an outside gem. So we're going to go over that right now. So if we're going to mock or stub our access to the internet, we need to pull the part of our code that accesses the internet out. So we're going to take this curl line and move it into a class called requester. Requester has one method, makeRequest, that takes a URL, and since I need an authentication key for this API, I'm going to throw the key in. And then I change my implementation to call makeRequest. Fairly simple refactoring. Since we're refactoring, we rerun the tests. Tests still pass, so we know that the refactoring worked. So now's the fun part, where we get into stubbing and mocking. We're going to make a stub requester class that inherits from requester, and our stub requester is going to have a collection of canned responses. You can put these in a file, you can put these in a database. I'm going to put them in a global variable because I only have about 12 lines on these slides. So what we're going to do is we're going to use the URL to look up our canned response, and we're going to return it. So simple hash lookup, that's all we got. So we have to change our implementation slightly so that we can change the requester out from underneath it. So we pass that into the initializer. When I've done this in the past, we've typically had code already attached to this implementation, and you don't want to have to change that code, and you don't really want your people consuming your code to know about your two requesters. So make sure the default is the one that hits the internet. The default is the one that people generally want. So make that change, refactoring, rerun our tests. Hey, they pass again. Awesome. Now we edit our tests to use the stub requester. All we have to do is pass in that argument with the class that we just built, and we rerun our tests, and everything blows up because we don't have a canned response for this URL yet. And thus far, we haven't done anything that WebMock doesn't do for you out of the box, and this error message is a lot uglier than what WebMock gives you if you try to hit the internet. So this is where it gets awesome. When I've used WebMock in the past, one of the challenges I've had is that I don't know, I need to have it return a specific response, and I need to know what that response should look like. So let's see if we can change our stub requester class to make that easy. So let's add a simple if statement. If we have a canned response, we should return it. Otherwise, we should access the internet. Well, we already have code that accesses the internet, and we're inheriting from the class that has that code, so let's just call out to super. And that's all great, except for the fact that I know, based on places that I've worked, if I just call out to super in that case, people aren't going to actually put the stubs in the way they're supposed to. So let's make sure that raises so that the test still fails, but gives you the output that you want, gives you the result of what you would get if you had hit the internet. And since to make the canned response, I also need the URL, let's throw that in the raises, let's throw that in the exception message as well. And let's see how this works when we run it. So we get an error. We expected that because we didn't actually have a canned response. But the runtime error we get starts with the URL that we tried to hit, and then it gives you the response. And I've cut the JSON response for length. Trust me, it does come back, and it's really long. And since we're raising, we also get a stack trace, but you can safely ignore that in this case. So now I have all the information I need to set up a canned response in my stub requester class. So I just copy and paste it in. Put URL, and then for the key, and the associated value is the response that we just got back, that we just showed up in our test output on our console. We rerun our tests, and we're down to less than 1,000th of a second. So for comparison, we started at 1/4 of a second. Less than 1,000th of a second. Significantly faster, doesn't hit the internet, and validates our responses. Oh yeah, and you have an example of what you're expecting the external web service to return, and I have used these files in negotiation with a web service when they said, no, we didn't change our API. I'm like, actually, yeah, you did. Here's all the information and the dates where I got this information from you guys. So another anti-pattern that really bugs me, complicated to set up. I did a bunch of research for this talk, and I also heard this called requires the world. You may have this anti-pattern in your code base when Testing a single model or a single controller requires instantiating all the other fixtures in your Rails app. Or when testing a single class requires instantiating 6 or more other classes. Depending on who you're asking, it may be 2 or more, 4 or more accurate, but 6 is a lot. And sadly, this isn't a testing anti-pattern. This is an implementation anti-pattern. So the solution is to refactor your implementation. And sometimes that's really, really hard. Hard enough that I'm not going to go into it in this talk. Instead, I'm going to recommend this book, Working Effectively with Legacy Code by Michael Feathers. The vast majority of this book is talking about putting large apps that are tangled together with mixed responsibilities, under test so that you can refactor them and make them more sane. Highly, highly recommend it. It's one of the best books on software that I've ever read. Onward to messy tests. I really like that elephant. So you may have messy tests if you have lots of repeated code in your tests. You find yourself writing tests via the copy, paste, and then tweak slightly method of test authoring. Your tests are disorganized, and a good hint that your tests are disorganized is when you find the same test in 2 different files, or worst case, and I've done this, you find the same test in 2 different places in the same file. Sometimes even with the same name. And your tests are also disorganized or messy if you have literals everywhere. And just like messy code, the solution to messy tests is to refactor. So some tips on test refactoring. Dry isn't just for your implementation code. Dry applies to your tests. Take repeated blocks of code, make them into methods, call the methods, give the methods good names. Group your tests by method under test. RSpec makes this sort of implicit with the describe and context blocks. You can do the same thing in test unit. I've generally done it by throwing a comment in with the name of the method under test, and then underneath that, all of the tests for that method go. Also, use descriptive names for your tests. We are no longer in the punch card days. We are not being charged by the character. If you need to have a 50-character test name, go for it. Make sure that if there are special preconditions, that's somewhere in the test name. Make sure that you know if it's a test for valid or if it's a success case or an error case that you're testing. And finally, put your literals into variables. I'm really bad about this, and it's something I've been getting a lot of help with at my current job, is to remember to put your literals into variables so that if you have to change them, you can only change them once. You don't have to change them 12 times across 3 files. And finally, the anti-pattern that everyone's probably been waiting for, even though you didn't know it. Slow tests. Everyone has a different definition of slow. I'm not going to give you mine. But common reason for slow tests. Having other testing anti-patterns somewhere in your code base. So if you're doing anything that I've covered up to this point, there's a pretty good chance your tests are going to be slow. Accessing external resources is a big one. Having tests that involve lots of setup. Anyone here have a test that imports an entire database from a dump before they run their tests? I've worked on that project. Those tests were slow. Don't do that. And finally, the biggest reason that I see for slow tests isn't because there's something inherently wrong with the test framework. It's because the implementation is slow. Here's an example of 2 tests. One that's fast, because all it does is assert true. One that's slow because it calls myClass.slowMethod. Slow method may or may not sleep for 5 seconds, and then asserts true. And the first thing you should do when you're confronted with slow tests is you should fix your implementation. Speeding up your feedback cycle for your developers will benefit your users. It will make everyone happier. But maybe your company doesn't really fully grok the whole benefit of testing yet, or maybe this method is only run once every 6 months in production, and so you can't justify spending the 3 weeks it's going to require to make it faster right now. In that case, you have one other tool up your sleeve, and that's using guards. So here are those 2 tests again. Here's what you have to do to make it so that slow test doesn't run by default. We're just going to check an environment variable, and if that environment variable isn't set, we're going to skip that slow test. So we run our tests the normal way. We only run one test, see, 1 dot. And the tests run really quickly, again, sub 1,000th of a second. Add the environment variable to our call, and now the tests are going to run faster. Or the tests are going to run slowly, but we're going to run both of them. This is a really powerful pattern. I showed someone this, and they immediately put it everywhere, and then we stopped running all those tests even in the CI. Don't do that. If you're going to do this, use it for the developers who don't need to care about the slow test. Make sure that your CI, either in the primary run or maybe a subsequent run, if you're using a tool like Jenkins that allows you to spawn separate test runs from your initial run, Make sure those tests are still getting run often, at least once a day, or preferably with every check-in. So my top 3, not running your tests. If you have them, run them. Benefit from the work you've already done. Order-dependent tests. I think this is a really important anti-pattern for people to understand because it pops up at the most odd times and it's really hard to debug if you've got a lot of code. And finally, requiring external resources is a huge pet peeve of mine because I like to be able to write code at coffee shops and on airplanes and things. Don't require external resources. So thank you all, and thanks to Creative Commons for all these wonderful photos I managed to use for today's talk.